Right. Good evening, students. Okay. First of all, I would like to welcome you all for this revision session for SSC JEE 2024 on building materials. Okay. My name is Uday Kiran. I am building materials faculty in ACE Engineering Academy. Okay. So, in today's session, in this 1 hour, we will be dealing with the revision of the topic building materials as part of SSC JEE 2024. See, next month, okay, we have the paper 1 examination, paper 1 of SSC JEE. Okay, so for that paper 1 examination, okay, in civil engineering, that is the part B of paper 1, which deals with civil engineering paper. Okay, in that, building materials is a very important topic. So we will be revising the topic as per the syllabus of the examination, and that revision we will be doing by solving some important objective questions. Okay. So, see, this is a revision session along with practice of solving the questions. Okay. How and which type of questions are being asked in the exam, okay, and how you should attempt the questions. Okay. So that aspect will also be dealt with in this session. Okay. So first, let us look into the syllabus as per the notification. So regarding building materials and concrete technology, okay, this is the syllabus as given in the notification. So see, regarding building materials, okay, see, physical and chemical properties, classification, standard tests, uses and manufacture or quarrying of materials. Okay. So basic physical and chemical properties, classification and standard tests regarding materials like building stones, silicate based materials, cement, okay, your Portland cement, asbestos products, okay, timber products, that is timber or wood based products, laminates, bituminous materials, paints and varnishes. Okay. So for these building materials, okay, physical and chemical properties, classification, standard tests and manufacturing or quarrying methods, okay, those aspects are covered in the syllabus. Okay. Coming to concrete technology, see, concrete, properties of concrete, advantages and uses of concrete, cement aggregates, importance of water quality, water cement ratio, workability, mixed design, which is a very important concept, okay, storage of concrete, batching, mixing, placing, compaction, finishing and curing of concrete, quality control of concrete, that is different testing regarding quality of concrete, okay, hot weather and cold weather concreting, repair and maintenance of concrete. So as per the notification, this is the syllabus for building materials and concrete technology. Okay. Now see, not only about this topic, see, for any topic, understanding the syllabus plays a very important role for your success in the examination. See, if you understand the syllabus properly, okay, then you will have a good idea on your preparation strategy, on how you should prepare for the exam. Okay. So which topics you have to focus on, okay, which topics are to be given importance, okay, so that aspect you can clearly do that by understanding the syllabus. Okay. Now coming to the weightage of the topic in SSC JEE paper 1. Okay. See, the paper 1 of SSC JEE, total it is for 200 marks. Okay. So 100 marks are your general ability, etc. Okay. Your part B deals with civil engineering. Okay. That civil engineering, you have 100 questions for 100 marks. Now, in recent years, it has been observed that a good weightage is given for building materials and concrete technology. Good weightage is given. Okay. So, if you look at 2022, okay, 2022, okay, your exam date and number of questions, you can clearly see that out of your 100 questions, okay, almost 8 to 12 questions are from your building materials and concrete technology. Okay. Coming to 2023, that is last year SSC JEE paper. Okay. So, here slightly there is an increase in weightage for this topic. Okay. So, around 8 to 15 to 16 questions are being asked from building materials and concrete technology. Okay. Now, see, not only SSC JEE, if you look at any recruitment based examination, okay, for civil engineering posts, okay, if you look at any recruitment based exams, what you will observe is out of 100 questions, okay, generally 8 to 12% are from building materials and concrete technology. Okay. This is a general observation. See, that same thing we can observe in SSC JEE as well. Okay. Any recruitment based exam, okay, building materials and concrete technology has a good weightage around 8 to 12%. So, that's why this topic is very important. Okay. Now, see, there are certain advantages when it comes to building materials, okay, exam point of view. Okay. See, both aspects we will be dealing here, exam point of view and your field or your professional job requirement aspect also will be dealt here. Okay. See, exam point of view, the weightage is quite significant, and the advantage with the topic is, okay, see, building materials, okay, if you properly prepare for the topic, that is going through your lectures, okay, material, if you solve previous year's questions, and if you do good revision, okay, nothing more than this, okay, follow the class or lectures, okay, printed material which you must be having regarding the topic, solving previous year's questions and doing good revision. Okay. These 4 aspects, okay, will help you fetch good marks in this topic. Okay. See, compared to other topics, the topic is relatively simpler, okay, compared to other topics like your strength of material, structure analysis or fluid mechanics. Compared to those topics, it is a relatively simpler topic, and proper preparation, okay, in a limited time, okay, you can do proper preparation regarding this topic, and that is a preparation point of view. Exam point of view, see, there is a good weightage for the topic, and the questions are, you can attempt the questions, okay, relatively faster compared to other topics. See, 99.99% of the questions on building materials and concrete technology are theory based, and if you have good conceptual clarity, okay, it will help you attempt the question, okay, relatively faster compared to other topics. See, other topics, again, your strength of materials, fluid mechanics, okay, see, those topics, okay, numerical questions can be asked, okay, which may take considerable amount of time, but building materials, okay, see, if you are prepared for the exam well, you can attempt the questions very fast, and you will have good time to solve your other questions from other topics. So, in that way, good preparation, okay, the weightage is good, and you can solve the questions in relatively less time compared to other topics. So these things considered, okay, you have to have good preparation for this topic. Okay. So that is about weightage of this topic in SSC JE. Okay. Now see, this is the syllabus as given in our notification. So to make things simpler, okay, what I have done is, see, these are all the building materials which we have to study for the exam. In simple terms, okay, these are the topics, these are the building materials which we have to understand. Okay. So in all these topics, okay, our focus should be on the source or manufacturing of the material. That is, if the material is freely available in nature, how do you quarry it or store or source it? Okay, that aspect has to be studied. Okay. If the material is not freely available in nature, then how the material has to be manufactured? That aspect has to be studied. After that, what are the relevant engineering properties and tests for these materials? Okay. And finally, we have to understand the applications of these materials. Okay. See, by understanding the source or manufacturing properties and applications, okay, you will have a good understanding on how to properly utilize these materials at the site. Okay. So as I told you earlier, this topic, okay, it will be helpful for exam because of the good weightage, yes. Along with that, okay, once you get into the service, okay, knowledge of this topic will help you become a good engineer at site. Okay. You can properly manage the materials, properly utilize the materials for the projects. Okay. So this topic has a dual advantage. Okay. See, compared to other topics, see, once you get into the service, okay, most of the cases you may not be requiring the complicated formulas of your structure analysis or fluid mechanics. Okay. In some cases, yes, knowledge that those topics are very helpful and important, I agree, but for most of the cases, okay, building materials knowledge and construction technology, okay, project management related concepts are practically very useful. So exam point of view, okay, so simply we have to study these materials in those three aspects. What are the three aspects? Source or manufacturing, properties and applications of these materials. Okay. So what these, as per the syllabus, we have to cover cement, aggregates, concrete, okay, bricks, ceramics, stones, asbestos, timber, paints and varnishes. Okay. Now out of these 9 topics, okay, you have to give high weightage to topics like cement. Okay. So good number of questions are asked on cement topic. Then concrete is important. Okay. Bricks is also an important topic. Stones, another important topic, and timber. Okay. See, out of these 9 topics, okay, the weightage for these 5 topics is relatively higher compared to other materials. Okay. So out of all these, okay, cement, concrete, bricks, stones and timber, okay, they are quite important. Okay. Even if you have solved previous year's questions, you will observe that many questions are being asked from these building materials. Okay. So with that basics, okay, we will try to solve some important questions which may be asked from these topics. Okay. So starting with cement, okay, a very good question. Sorry, which of the following, spelling, okay, so typing error, okay, which of the following raw materials is not used, okay, which of the following raw materials is not used in the manufacture of any cement. Okay. Which of the following raw materials is not used in the manufacture of any type of cement? Okay. Now, in cement topic, you must have studied there are 15 different types of cements. Okay. Out of all those 15 type of cements, ordinary Portland cement is the most important cement. Apart from that, there are 14 other cements which have different applications. Okay. Now, for different type of cements, in some cases different raw materials we will be using for their manufacture. Okay. Now, so for any cement, okay, which of the following raw materials is not used? So options are limestone. Yes, see, limestone is used for manufacturing of almost all type of cements, okay, including ordinary Portland cement. So this is not the correct option. Bauxite, see, we use bauxite in the manufacture of high alumina cement. Okay. So it is also used in the manufacturing of a particular type of cement. So bauxite is not the option. Okay. Now look at chalk, option D. See, chalk is used in the manufacture of white cement. So this is not the right option. Okay. Now option C is hematite. See, hematite, okay, is an ore for the manufacture of iron. Okay. We don't use hematite in the manufacture of any kind of cement. Okay. So this is the right option. Okay. So see, here I would like to tell you that, see, in cement chapter, types of cements is a very, very important topic. Okay. So do study the different type of cements, the 15 type of cements. Okay. So a question can be asked in regarding any of the type of cement. Okay. Right. Next question on cement. The cement compound which is responsible for its early rate of strength gain is. Okay. So which cement compound is responsible for its early rate of strength gain? So early rate of strength gain of cement depends on which of its compounds. Okay. Now, so see guys, we know ordinary Portland cement primarily contains 4 compounds called as Bogue's compounds. They are tricalcium silicate, dicalcium silicate, tricalcium aluminate and tetracalcium aluminoferrite. Okay. Now, early rate of strength gain. Okay. See, early rate of strength gain is primarily due to the presence of tricalcium silicate. Okay. Now, see, out of the 4 cement compounds or Bogue compounds, okay, tricalcium silicate, dicalcium silicate, tricalcium aluminate and tetracalcium aluminoferrite. Out of these 4 compounds, strength primarily comes from C3S and C2S. Okay. So the strength, it comes from C3S and C2S. Now, tricalcium silicate reacts with water very fast. Because of that, okay, it contributes towards the initial strength, also called as early rate of strength gain of cement. Okay. Now, dicalcium silicate also contributes towards strength, but because this compound reacts with water very slowly, okay, its contribution towards initial strength is very less, insignificant. Okay. So early rate of strength gain, okay, it is due to tricalcium silicate because it reacts with water very fast and the hydrated compound, that is calcium silicate hydrate, okay, it gives strength to the structure. Okay. So correct option is tricalcium silicate. Okay. Now here similar question can be asked on the same concept. Okay. A question like, okay, later stage strength development in cement primarily comes from which compound? Okay. So see, early rate of strength gain is due to tricalcium silicate. Later stage strength development in cement is due to dicalcium silicate. Okay. Now, the reason for this is because C3S reacts with water very fast, okay, by the time you reach 10 days, most of your C3S has reacted with water. Okay. So, now the later stage strength development, that is a 14 to 28 day period, strength gain during that period is due to C2S, because by that time C3S has almost reacted completely with water. So, what you are left with which is giving strength is C2S. So, later stage strength development comes from dicalcium silicate. Okay. Early rate of strength gain is because of tricalcium silicate. Okay. It's a very important question, has been asked many times in many different exams. Right. Next question. Which of the following apparatus is not used for testing cement properties? Okay. So, here certain test apparatus are mentioned. Okay. So, which of these test apparatus are not used for testing cement? Okay. Cement properties, okay, is not used. See, in cement chapter, okay, testing of cement is very important. Okay. So, in testing of cement, you have consistency test, initial setting time, final setting time, okay, soundness tests, fineness tests, compressive strength tests. These tests are very important for exam. Okay. Now, so let us look at the options. Vickard's apparatus. Now, where do we use Vickard's apparatus? See, Vickard's apparatus is used for 3 tests of cement. They are: 1, standard or normal consistency test, we use Vickard apparatus. Initial setting time test, we use Vickard apparatus. Final setting time test, again we use Vickard apparatus. So, this is not the option. Okay. See here, question it is asked, apparatus is not used for testing the properties of cement. So, we use Vickard apparatus in 3 tests, so it is not the right option. Lee-Chartless apparatus, so this is also not the correct option, because Lee-Chartless apparatus, which is a split cylinder, we use it for testing the soundness of cement due to excess presence of free lime. Okay. So, we know that if the cement contains excess amount of free lime, then the cement will become unsound. Okay. So, that property is tested by Lee-Chartless apparatus, which is a split cylinder made of spring brass material. Okay. So, this is also not the right option. Devil's apparatus. Okay. Now, then finally we have Brickett's apparatus. Now, this is also not the right option, because Brickett's apparatus we use it for the tensile testing of cement. Okay. For determining the tensile strength of cement, we use Brickett's apparatus. Okay. So, this is not the right option. The correct option is Devil's apparatus, also called as Devil's testing machine. So, Devil's testing machine, we do not use it for testing cement, we use it for testing the attrition value, of aggregates and stones. Okay. This test has nothing to do, the apparatus has nothing to do with testing of cement. Devil's apparatus or Devil's testing machine is used for determining the attrition value of aggregates and stones. So, option C is the right option. Okay. So, next, which of the following cement compounds has no role in sulfate attack? Okay. So, out of these 4 cement compounds, which compound has no role? Okay. No role in sulfate attack. Okay. Now what is sulfate attack? See, sulfates present in cement are sometimes absorbed from soil which is in contact with concrete. Okay. Sulfates, it can be sodium sulfate, magnesium sulfate, anything. Okay. Now, these sulfates which are present in cement are absorbed from soil, they react with calcium hydroxide produced by the hydration of C3S and C2S. See, we know hydration of tricalcium silicate and dicalcium silicate produces calcium hydroxide, a byproduct. Okay. Now, the sulfates present in cement or absorbed from soil react with the calcium hydroxide produced by the hydration of C3S and C2S to form calcium sulfate. Now, that calcium sulfate further reacts with the hydrated compound of tricalcium aluminate. Okay. So, the hydrated compound of tricalcium aluminate reacts with the calcium sulfate. Okay. So, that reaction causes expansion in concrete. Now, due to this expansion, which is very slow, sometimes it takes weeks, months and years to have some observable expansion. Now, due to that expansion, cracks are formed in concrete, due to which strength and durability is lost. Okay. So, that phenomena is called sulfate attack. Okay. I will repeat this one more time. Sulfates present in cement or absorbed from soil react with the hydrated compound, react with calcium hydroxide produced by the hydration of C3S and C2S to form calcium sulfate. That calcium sulfate further reacts with the hydrated compound of tricalcium aluminate to cause expansion and deterioration in concrete. The whole process or phenomena is called sulfate attack. Now, as per this definition, it is very much evident that tricalcium silicate and dicalcium silicate, they have an indirect role in sulfate attack, because hydration of these compounds is producing calcium hydroxide, which is reacting with sulfates to form calcium sulfate. So, they have a indirect role in sulfate attack. Coming to tricalcium aluminate, okay, tricalcium aluminate, when it gets hydrated, that hydrated compound is reacting with calcium sulfate, which is produced when sulfates react with calcium hydroxide. Okay. So, it also has a role in sulfate attack, but in the whole process, in the complete definition, we haven't seen the presence of or the effect of tetracalcium aluminoferrite. Okay. So, with that we can deduce that tetracalcium aluminoferrite, denoted by C4AF, tetracalcium aluminoferrite denoted by C4AF, has no role in sulfate attack. Okay. So, very, very important objective point. Right. Now, next, another question on cement. Which of the following cements is best suited for constructions in cold weather conditions? Okay. So, see, in situations where the climatic conditions, weather conditions are very cold, okay, now in those circumstances, okay, we don't prefer ordinary Portland cement. Okay. Now, see, in cold weather conditions, we will prefer a cement, okay, which has high heat of hydration and high early rate of strength gain. Now, what is the reason for that? See, if you use ordinary Portland cement in cold weather conditions, because of the low temperatures, hydration is slower. Because of that, your setting and rate of strength gain are slower. Okay. So, that is not desirable, because slow setting and slow rate of strength gain means the project will get delayed. Okay. There will be delay in the project because of the slow setting and hardening. Okay. Now, to avoid that problem, instead of ordinary Portland cement, we will prefer a cement which has high initial strength and high heat of hydration. Okay. So, because of that high heat of hydration, okay, the hydration process will be faster. Okay. Because of the heat generated during the hydration, the overall process will become faster. Okay. So, that kind of cement is preferred for cold weather conditions. Okay. Now, so two things you have to remember. One, the cement should have better initial strength compared to OPC. Two, the cement should have high heat of hydration compared to OPC. So option C, low heat cement. No, this is not suitable for constructions in cold weather conditions because it has less initial strength compared to OPC and less heat of hydration compared to OPC. So we will reject that for cold weather conditions. Portland Pozzolana cement, again it is rejected. Reason being, Portland Pozzolana cement, because of the pozzolanic action, okay, early rate of strength gain is less and overall heat of hydration is also less. Okay. Blast furnace slag cement, again we cannot use it for cold weather conditions because blast furnace slag is also a pozzolana material. It behaves similar to Portland Pozzolana cement because of the pozzolanic action. Blast furnace slag is also a pozzolana material. Okay. So both have similar properties. So initial strength is less and heat of hydration is less. So not suitable for cold weather conditions. Rapid hardening cement. Okay. This cement is preferable for constructions in cold weather conditions because rapid hardening cement gives high initial strength compared to ordinary Portland cement, and this cement has high heat of hydration compared to ordinary Portland cement. Okay. So because of that, the cement is suitable for constructions in cold weather conditions. Now, apart from this cement, another cement which is suitable for constructions in cold weather conditions is high alumina cement. Okay. Okay. Sometimes in the options rapid hardening cement may not be given. Instead of that, high alumina cement, if it is given in the option, it is also correct. Okay. High alumina cement, this cement also has high initial strength and high heat of hydration. So it is also suitable for constructions in cold weather conditions. Okay. Right. So guys, see, on 26th of May, okay, ACE Engineering Academy is conducting SSC JE mega mock test. Okay. So see, mock tests will help you prepare get the exam orientation, okay, and it's very important as part of your preparation strategy. See, just studying the topics is not sufficient, okay. You should be exam ready. To be exam ready, mock tests are very important, okay. So to help you prepare in a better way, okay, ACE Engineering Academy is conducting SSC JE, okay, mega mock test, which is on 26th of May. Okay, it is done in online mode, which is similar to your actual examination of SSC JE. Okay, so do take this test for your evaluation and for you to become exam ready. Okay, do take this test, that will be helpful for you. Okay. Now, practice questions regarding your another important topic, aggregates. Okay. Now, questions on aggregate, let us see. Which of the following is an example of natural aggregate? Okay. So, see, this question is coming from the subtopic of aggregates, that is classification of aggregates. Okay. So, classification of aggregates, we have natural aggregates, we have artificial aggregates. Now, what are natural aggregates? Aggregates obtained from natural rock formations like igneous, sedimentary and metamorphic rocks. So, if you are obtaining the aggregates from these natural rock formations, then they are called natural aggregates. Now, what are artificial aggregates then? Aggregates obtained from byproducts or waste products of industries. Okay, see, iron industry, brick industry. Okay, see, these industries, example, okay, the waste generated from these industries, they are processed to get some aggregates. They are called artificial aggregates. Okay. Now, so which of the following is an example of natural aggregate? Now, option A, granulated blast furnace slag, incorrect option. Okay. See, blast furnace slag, it is a waste coming from your steel and iron industry. Okay. Rapid quenching of this blast furnace slag gives granulated blast furnace slag, which is a artificial coarse aggregate, which is a artificial coarse aggregate. So, not the right option. Then we have surki. Surki is also not a natural aggregate, because how do you get surki? Powdered bricks is called as surki. See, brick is a man-made material, okay, which is you don't find bricks naturally available or freely available in nature. We make bricks by burning clay. Okay, because of the fusion of clay particles, okay, bricks are formed. Okay. Now, by crushing the bricks, you get a artificial fine aggregate called as surki. Okay. So, it is a artificial fine aggregate. So, not the right option. Now, next is laterite. This is the correct option. Sorry. Okay. Laterite is the correct option because laterite is a argillaceous sedimentary rock. Okay. Argillaceous sedimentary rock. Okay. So, I told you what is a natural aggregate? Aggregate obtained from natural rock formations like igneous, sedimentary or metamorphic rocks are called your natural aggregates. So, laterite, it is obtained, it is from sedimentary rock. Laterite is a sedimentary rock, which is a natural material. Okay. Hence, it is an example of natural aggregate. Okay. Aggregate obtained from laterite, they come under natural aggregates. Okay. Right. Next, the test which is used for assessment of both coarse and fine aggregates is. Okay. So, this question is from the subtopic testing of aggregates. Okay. So, for aggregates we have different tests which are flakiness and elongation index test, aggregate crushing value test, aggregate impact value test, aggregate abrasion value test. Then we have soundness test, okay, fineness modulus test, bulking test. Sorry. So, these tests, they come under testing of aggregates. So, the question is, which test is used for the assessment of both coarse and fine aggregates? The test which is used for testing coarse aggregates as well as fine aggregates. Okay. So, first is flakiness and elongation index test. This option is incorrect. See, flakiness and elongation index test is a test done only on coarse aggregates. We don't do this test on fine aggregates. Okay. So, this is a incorrect option. Next, aggregate impact value test. This option is also incorrect. See, aggregate impact value test, the test is used to assess the toughness of coarse aggregates only. Okay. We don't use it for testing of fine aggregates. So, this is used for testing of toughness of coarse aggregates. Okay. Fineness modulus test. Okay. This option is correct. Okay. See, fineness modulus value, it is calculated for both coarse aggregates and fine aggregates. The fineness modulus value, it is very helpful in concrete mix design as per IS 10262-2019. Okay. So, fineness modulus of coarse aggregate, fineness modulus of fine aggregate, they play a very important role in concrete mix design. Okay. So, fineness modulus is calculated both for coarse and fine aggregates. So, this option is correct. Now, aggregate abrasion value test. No. Aggregate abrasion value test, it is used to assess the hardness of only coarse aggregates. We use Los Angeles testing machine, you must be remembering that. Okay. So, aggregate abrasion value test, it is used for assessing the hardness of coarse aggregates only. We don't use it for testing fine aggregates. So only option C is correct. Next. The phenomena of bulking of sand is due to. Okay. So what is the main reason behind bulking of sand? Capillary action, surface tension, cohesion, none of the above. No, it is not capillary action. See, what is capillary action? It is the rise in water level due to surface tension is called capillary action. Okay. Now, bulking of sand is not at all related to capillary action. See, what is bulking? Okay. What is bulking of sand? Okay. Apparent increase in volume of aggregates due to presence of some moisture is called bulking. Okay. So, but capillary action generally observed in saturated conditions, but bulking is not observed in saturated condition. Bulking is observed in fine aggregates when there is some moisture, generally around 2 to 6% moisture. Okay. Some moisture is present, that will cause bulking. Okay. Capillary action is observed when there is saturated conditions. It is not at all related to bulking of sand. Okay. So bulking of sand is because of surface tension phenomena. Okay. See, what is happening in bulking? Okay. If there is some moisture present between the aggregates, water films are formed between the aggregates. The films, they have a surface, so surface tension kicks in. Surface tension, okay, it will hold all the particles in suspended form. The surface tension will not allow the aggregate particles to come closer. Okay. So because of that, there is a apparent increase in volume, okay, that is called bulking. Okay. So bulking, see, exam point of view, it's a very important concept. Bulking is observed mainly in sand and silt. Okay. You don't observe bulking in coarse aggregates. You don't observe bulking in clay. Okay. Because in coarse aggregates, the weight dominates the surface tension forces. Hence, no bulking is observed in coarse aggregates. In clay, the cohesion between clay particles dominate the surface tension forces. Hence, clay does not show any bulking. So bulking is observed mainly in sand and silt. That is due to phenomena of surface tension. Very important question, has been asked many times in many exams. Next. So next, concrete, very important topic for exam point of view. So some practice questions regarding concrete. As per IS 456-2000, during placing of concrete, it must be ensured that the concrete does not fall from a height more than dash. Okay. See, in concrete preparation, we have different steps. First is batching, that is measurement and proportioning of ingredients is called batching. Then you have mixing, transportation, placing, compaction, okay, curing and finishing. These are the different steps involved in concreting. Now, out of these steps, okay, placing of concrete is an important step. Now, IS 456-2000 states that when you are placing the concrete in the formwork, you should make sure that concrete does not fall from a height more than 1.5 meters. Okay, that is 5 feet. Now, there is a reason for that. See, if you dump the concrete from a height more than 1.5 meters, what happens is, we have two problems. One, see, concrete is a very dense material. So if concrete falls from a height more than 1.5 meters, because of the impact, concrete may undergo segregation. That is one problem. Second, again, because concrete is a dense material, okay, if you throw it from a height more than 1.5 meters, okay, the impact can disturb the formwork. Okay, the impact may disturb the formwork. And please remember, during concreting, last moment corrections in formwork is practically impossible. Okay, so it's very difficult to do any last moment corrections during concreting. Okay, so there will be lot of frenzy when concreting is being done. Okay, so you don't have time for any kind of repair works in the formwork. So to avoid these problems, one, to avoid segregation, two, to avoid any disturbance to formwork, IS 456 says concrete should not fall from a height more than 1.5 meters. Very important objective question. Right. Next, which of the following admixtures can be used to delay the setting of concrete? Okay. So now you may ask me, sir, why do you want to delay the setting of concrete? See, this is very important when you are going for ready mix concrete. Okay. Ready mix concrete you must be knowing. Okay. So in the faraway batching plants, concrete is prepared. Okay. It is brought to the site using transit mixers. Now, due to some problem, if there is some delay in getting to the site, okay, or if the site is little far away, okay, then what happens is, because of the delay, okay, concrete may set a little bit, because of which workability is reduced. Okay. So to avoid that problem during transportation, okay, if we feel that there is going to be some delay or there will be some setting which may hamper the workability of concrete, then admixtures called as retarders are to be mixed with concrete. Okay. So retarders, they delay the setting of concrete. Because of the delay, by the time concrete reaches the site, it will have the required workability. Okay. So for that we use retarders. Calcium chloride is not a retarder, it is an accelerator. If you use calcium chloride, okay, the concrete will undergo faster setting, so we cannot use this. Okay. Zinc fluoride, again it is not a retarder. Okay. Common sugar, yes, common sugar is a retarder, it has a retarding action. Okay. So to delay the setting of concrete, we can use common sugar. Okay. So sugar solution can be mixed with concrete, because of which there will be some delay in concrete, setting of concrete. Apart from common sugar, you can also use gypsum. Gypsum is a naturally occurring mineral. Okay. Now, not everywhere gypsum may be available. Okay. So if gypsum is not available, then use common sugar. Okay. Sometimes gypsum may be given the option, so gypsum is also correct. It is also a retarder. Okay. Right. Next, workability of concrete primarily depends on which of the following factors? Very important question. Okay. Workability of concrete. Okay. See, first of all, what is workability of concrete? So how easily concreting can be done, it is called as workability. So the definition goes like this: the ease and homogeneity with which a freshly prepared concrete can be mixed, placed, compacted and finished. Okay. How easily you can do these concreting tasks, that is called as workability. It's a qualitative concept. Okay. If you can do all these concreting tasks very easily, then workability is said to be high. If lot of physical effort is required for mixing, placing, compaction and finishing, then workability is said to be low. Okay. Now this workability depends on many factors. Okay. Water cement ratio, aggregate cement ratio, water content, shape of aggregates. See, all these factors, they affect the workability of concrete. But our question is, workability of concrete primarily depends. Okay. So out of these four, see, all four affect the workability of concrete. But out of these four, workability is mainly affected by which factor? Okay. So what is the main factor out of all these? That is water content. Okay. See, more the water content, more will be the cement paste in the concrete mix. Okay. So, see, cement paste helps you in workability by acting like a lubricant. If there is more cement paste in the concrete mix, it is very easy for mixing, placing, compaction and finishing. See, you may have very high, water cement ratio may be low, or other factors, they may be reducing the workability, but if water content is more, okay, it will significantly improve the workability of concrete. So, workability of concrete primarily depends on water content. Now, what is water content? Okay, how many liters of water? Liters or kgs, both are same. Okay, 1 gram density of water, 1 gram per cc. Okay, so how many liters or how many kgs of water is required to make 1 cubic meter of concrete? Okay, that is termed as water content. Okay, so that is termed as water content. Workability, okay, primarily depends on this factor, water content. Very important question, has been asked many times in many exams. Okay, now next question. The temperature below which cement does not hydrate is, okay, now, see, this question is from a concept called as maturity of concrete. Okay. This question is from the concept called as maturity of concrete. Okay. So, maturity of concrete tells us how far curing of concrete has progressed in a given period. Okay. Now, see, it's a factual question. Okay. So, see, what happens is cement and water, if they are in contact, okay, so what happens? Hydration will occur. Now, for that hydration to happen, the temperature should be more than minus 11 degrees centigrade. It's a very important fact, please remember that. Okay. See, if the cement particles and water are in contact, and if the temperature is less than minus 11 degrees centigrade, then cement will not react with water. So, the minimum temperature for hydration to occur is minus 11 degrees centigrade. Okay. Next, another practice question on concrete. Okay. In the mixed design of concrete as per IS 10262/2019, strength of concrete primarily depends on which are the following factors. Okay. So, see, in concrete mixed design as per IS 10262/2019, there are different steps involved. Okay. First step is calculate the target mean strength. How do you get target mean strength? Mean strength is characteristic strength plus 1.64 times standard deviation. So, standard deviation is given in this table, in the table of IS code. From that you can get the mean strength. Second step is, from this mean strength you will find water cement ratio. Okay. So, here very important objective point here is, see, this code considers, IS 10262/2019 considers that strength primarily depends on water cement ratio. Okay. So, strength primarily depends on water cement ratio. Okay. So, see, how is this relationship? Okay. So, the relationship between strength and water cement ratio is given by Abram's law. Abram's law states that strength of concrete and water cement ratio are inversely related provided the concrete is workable. Okay. So, that concept is utilized in concrete mixed design as per IS 10262/2019. Okay. There it is clearly stated that from the mean strength you will calculate water cement ratio, because strength is primarily dependent on water cement ratio. Okay. So, very important objective point. Next, the test used to assess the workability of highly workable concrete is, okay, see, we have different workability tests: slump cone test, VB consistometer test, compaction factor test, flow table test, Kelly ball test, okay, different workability tests are there, okay. Now, generally slump cone test is preferable for medium to high workable concrete, compaction factor test for low workable concrete, VB consistometer test for very low, almost dry mix workable, okay. So very low workable concrete we use VB consistometer test. Now flow table test, it is used for assessing the workability of highly workable concrete. Okay. For assessing the workability of highly workable concrete, we use flow table test. Next, we'll look at some questions on bricks. Okay. See, the compound which is present in brick earth in highest proportion is, see, to make bricks, we want brick earth which is clay. Okay. Now, a good brick earth will primarily contain silica, alumina, iron oxide and lime. Okay. Now, a good brick earth, okay, in a good brick earth, lime content is around 5%, okay, lime that too in powdered form should be 5%, silica around 50 to 60%, okay, silica is around 50 to 60%, alumina around 20 to 30%, okay, iron oxide around 5 to 6%, okay. A good brick earth will contain these four compounds in these proportions. So out of all these, highest proportion is for silica, okay. So silica, it is around 50 to 60%. Next, first class bricks are table molded and burnt in kilns, table molded and burnt in clamps, ground molded and burnt in kilns, ground molded and burnt in clamps. Now, so regarding first class bricks, okay, see, just by looking at the brick, okay, you can clearly say that it is a first class brick because first class bricks have uniform shape and texture. They have uniform shape and texture. Okay. Now, to get that uniform shape and texture, ground molding is not suitable. So, ground molding is not suitable. Eliminate these two options. Okay. See, in ground molding, the labor sits on the ground, okay, and makes the molded bricks on the ground. The ground is generally uneven, so you will not get a first class brick if ground molding is done. Okay. So, we use table molding, burnt in kilns or clamps. See, first class bricks, they have good strength. Okay. Now, for good strength, you cannot use clamps. See, what are clamps? Clamps are temporary masonry structures which give non-uniform and low quality bricks. So, we cannot use clamps for making first class bricks. Okay. So, to make first class bricks, okay, table molding is done and first class bricks are always burnt in kilns. First class bricks are always burnt in kilns. Okay. So, second class bricks, they are also table molded, second class bricks are ground molded but burnt in kilns. Third class bricks, ground molded and burnt in clamps. Okay. So, question is about first class bricks, they are table molded or sometimes machine molded, and burnt in kilns. Okay. Next, the test used to assess the freezing and thawing resistance of bricks is, okay. Now, what is freezing and thawing resistance? See, India is a tropical country, so we need not bother much about freezing and thawing effects, but if you look at the extreme northern parts of our country, okay, in winters there is freezing happening and in summers you have thawing. Thawing means melting of ice to water. Okay. Now, if a brick is in contact with water, where freezing and thawing effects are there, okay. Now, what happens is, during freezing okay, water converts to ice, and we know, okay, when water converts to ice, there is expansion. Okay. So the brick which has absorbed water, okay, if it undergoes freezing, the water will expand, cracks will be formed in the bricks. Okay. So freezing and thawing over a long period of time will lead to damage to the bricks. Okay. Now, which test effectively talks about the freezing and thawing resistance? It is water absorption test. Now, the logic is simple. If the brick is absorbing less water, okay, now the freezing, due to freezing, there will be less expansion, okay, because of which less cracks will be formed in the brick. Hence, okay, water absorption test is the correct test which will assess the freezing and thawing resistance of a brick. Okay. Soundness test is a durability test not related to freezing and thawing. Efflorescence test deals with presence of alkalis in bricks, nothing to do with freezing and thawing. Warping test is a shape and size test of the brick, again nothing to do with your freezing and thawing. So water absorption test is the right option. Next, which of the following statements regarding ceramic materials is not correct? Okay. So ceramic material, okay, see, ceramic materials, they have some important properties. One, all ceramic materials are formed by burning some kind of earth. Okay. Second, all ceramic materials are brittle materials. Okay. Next, all ceramic materials are amorphous solids. Okay, they are amorphous. Okay, internal structure, there is no regular pattern. Okay, the internal structure of ceramic materials don't have a regular pattern. Okay, so ceramic materials, they have amorphous internal structure. Okay, and all ceramic materials are brittle materials. Okay, so very small deformation may lead to failure in ceramic materials. They are brittle materials. Okay, so now, which of the following is not correct? They have poor electrical and thermal conductivity. Yes, okay, that is true. Okay, so option is incorrect because see, ceramic materials don't have free electrons, okay, in the structure. Okay, now because there are no free electrons in ceramic materials, they are poor conductors of heat and electricity. Okay, so statement 1 is incorrect. They have crystalline internal structure. Okay, that is the incorrect statement. Okay, see, all ceramic materials have amorphous internal structure. Okay, not crystalline internal structure. Okay, all ceramic materials are brittle materials. Yes, the statement is correct. Okay, so only option B. Okay, they have crystalline internal structure. No, that is, all ceramic materials have amorphous internal structure. Okay, next, question on stones. The test used to assess the presence of soluble matter in stones is, see, in stones topic, testing of stones is very important. Okay, there are 8 important tests for stones. 1, attrition test, we use Devil's testing machine. Smith's test for determining the presence of soluble matter. 3, acid test for determining the presence of calcium carbonate. 4, crushing test to determine the crushing strength of a building stone. Impact test to determine the toughness of a building stone. Hardness test to calculate coefficient of hardness of a building stone. Okay. Water absorption test and your microscopic test. Okay. So these 8 tests, okay, are important for assessment of a building stone. Okay. Now, the test used to determine, assess the presence of soluble matter is Smith's test. Okay. Smith's test will help you determine how much soluble matter is present in the stone. Okay. Attrition test will help you determine the hardness of stone. Acid test, it is used to determine the presence of calcium carbonate in stones. Hardness test to determine the hardness value of the stone. Okay, so presence of soluble matter. Okay, that is tested using Smith's test. Okay, the most commonly used method for seasoning of stones is. Okay, now what is seasoning of stones? See, seasoning means removing the naturally occurring moisture in stones is called seasoning. Okay. See, even after quarrying, even after dressing of stones, there will be some naturally occurring moisture in stones, that is called quarry sap. Removing this quarry sap is called seasoning of stones. Now, why do we need to do seasoning? Okay, seasoning will help improve the strength and durability of stones. Okay. If you remove that naturally occurring moisture, strength and durability are improved. Okay. Now, so seasoning of stones, it is done by cyclic drying and airing. It takes a lot of time, around 3 months to 6 months is needed. Okay. So your alternate cyclic drying and airing will help in seasoning of stones. Okay. Seasoning by boiling, natural or air seasoning, they are incorrect because they are used for seasoning of timber, not stones. Okay. For seasoning of stones, we use cyclic drying and airing. Okay. Next, asbestos. Okay. Which of the following statements is not correct regarding asbestos? Okay. Now, see, asbestos, naturally occurring fibrous material. Okay. Now, it has good electrical insulation property. Yes. Okay. We are asked for not correct statement. So, see, asbestos is it has very good insulating property. That's why asbestos is used in your transformers, switches, electrical circuits. Okay. It's a very good insulator. So, incorrect. It has good thermal insulation property. Yes, the statement is true. Okay. Asbestos, okay, it's a very good thermal insulation property. It has fibrous structure. Yes, it is also true. Hence, D. Okay. All the three statements A, B, C are correct. Okay. They are true statements. Hence, option D. Question is asked, which of the following is not correct? Okay. Hence, option D. Wood from which of the following trees can be used for making veneers? Okay. Now, what are veneers? See, veneers are thin sheets cut from hardwood. Veneers are, go by the definition, veneers are thin sheets cut from hardwood. Okay. Now, out of the given options, only oak is a hardwood. Chir is a softwood, pine is a softwood, bamboo is endogenous tree. Okay, it is not a exogenous tree, so not used for any veneer. Okay, we cannot use bamboo for making veneers. Veneers, they are thin sheets cut from hardwood. Hardwoods come under exogenous trees. Okay, hardwood trees come under exogenous trees. Okay, chir and pine are softwood trees, they are not correct. Okay. Bamboo is an endogenous tree, so this is also not correct. Only oak, it is a hardwood tree. Okay. So thin sheets cut from oak, they are used for making veneers. Okay. Now, next question. Sir Abel's process is used to improve which of the following properties of timber? Okay. It's a very important question. See, Sir Abel's process is used to improve the fire resistance of timber. Okay. See, Sir Abel's process involves 3 steps. 1, applying dilute sodium silicate on the timber. 2, applying a layer of flaked fat lime on timber. 3, applying a layer of silicate of soda. Now, by doing all these three, okay, the fire resistance of timber is improved. Okay, so Sir-Abel's process, it's a very important process. It is used to improve the fire resistance of timber. Okay. Next, commercial plywood is identified based on. Okay, now see, it's a very important and practical question. See, today if you go to the market and ask the vendor, okay, that you want to buy plywood, he will ask you two questions. Okay, which plywood you want? That is, how many veneers are required in that plywood? Two, what is the overall thickness of plywood you want? Okay, so commercial plywood is identified based on these 2 points: number of veneers and overall thickness. Okay, see, quality of plywood is directly proportional to both. Okay, for a given thickness, more the number of veneers, better is the quality of plywood. Now, for a given number of veneers, more the thickness of plywood, better is the quality of plywood. Okay, so commercial plywood is identified based on both number of veneers and overall thickness. Okay, next, the liquid which is mixed in an oil-based paint, important note, oil-based paint, to help in easy application on the surface is what? It is solvent. See, oil-based paints, okay, they have 5 parts. Oil-based paints have 5 parts: 1 base, 2 vehicle, 3 pigment, okay, 4 solvent, 5 dryers. Okay, so oil-based paints have 5 components. Out of these 5 components, solvent is used, which helps the workability, improves the workability of the paint. That is, easy application of paint, you need solvent. Okay, so the liquid which is mixed in an oil-based paint for easy application, okay, so that you can easily apply on the surface. Okay, without solvent, application of paint is difficult because of the less workability of the paint. Okay, that is the solvent. Right. So, guys, okay, with that we are done with our revision session for SSC JE 2024 on building materials and concrete technology. Okay, so before we conclude this session, okay, I would like to tell you that, see, building materials and concrete technology, they are theory based questions. So with good preparation, you can attempt the questions in very little time. So you will get more time to solve the numerical questions of other topics. The weightage, see, weightage is very good for this topic. Around 8 to 12% of your civil engineering paper. See, now that's a very good weightage because, see, out of your 100 marks of your civil engineering paper of paper 1, that is part B of paper 1, okay, you will get on an average minimum 10 questions average you will get. So that is a very good weightage. Okay. Now preparation strategy is simple. Okay, as I told you earlier, okay, follow the lectures or notes, go through the material, write test series, okay, mock tests, again, for which ACE Engineering Academy is conducting a mock test, which I told you. Okay, this mock test will definitely help you in your preparation. After that, revision, okay, proper revision will help you. Okay, do previous year's questions. Okay, now doing all these things, okay, will help you fetch good marks in building materials and concrete technology. Okay, so guys, with that I would like to conclude this session, and I wish you all the best for the exam coming next month. Okay, thank you.